Hey, what's up everybody? I was going to share a presentation I did at work, but I could not remove private information or faces from it, so I am just going to redo it. Not as exciting, there won't be a PowerPoint. I guess I can go through it if y'all really want me to. But before we get started, I do want to go over two resources. One is this Kubernetes 101. It is probably the only Medium article I've ever read and said, wow, that's interesting. I learned something. It's pretty good. It's from 2018, but it's still relevant. There's a lot of changes to Kubernetes all the time, but the underlying infrastructure remains mostly the same. So this is definitely still relevant. But the dude used watercolors to go over the Kubernetes basics, and I thought that was really interesting. It's definitely unique. It stuck with me, which is why I always remember to recommend it to people. He Bob Rossed the shit out of this. So it's definitely something I'm going to link later. And also I'm going to link Metal LB. So Metal LB is for on-prem load balancing. Kubernetes itself does not have load balancing out of the box. And the developers did this because I guess they wanted people to write their own, or if they wanted to use it with a cloud provider. So that's what happens when you use it on a AWS, Azure, Google Cloud. They have written their own load balancing integration with it. But if you run it on-prem, you really have to use your own, which often involves very expensive hardware. Fortunately, the developers behind Metal LB stepped in. So three things. One, you want to make sure that your network provider is compatible. I use Flannel. Flannel does require a specific CIDR IP, but they go through that in the docs if you go through it. WeaveNet I used to recommend, but because of the issues with Metal LB, I no longer recommend it. Now, Kubeadm is really nice. However, I suggest you look into it and just see where it's developed and maintained and where it originates from. That's all I'll say. I really don't want to influence you one way or the other. I think it's a great service. I just don't use it today. So look into it. Just research it if you're comfortable with it. Use it if not. Flannel is an incredible option. To get started, you really just run these two applies. Now for configuration, I use layer 2 because I'm just hosting on a KVM, and I use the software to do the networking and load balancing for me. If you're hosting this in an actual data center with networking hardware such as routers and load balancers, I recommend the BGP configuration. For my little home lab, this is overkill, but if you're actually running out of a data center, this will get you very powerful performance, very flexible networking, and it will work inside of your data center. So those are the things to consider: the network provider, the installation manifests, and the configuration. To apply this, what I did is I just swooped this up. I changed the addresses to be specific to mine. Now this address range is going to be applied to your services, so do not use, like, if a printer or if another VM has it, don't use this in a. What I'm saying is use a range that is not used by your DHCP service or something that you don't have statically assigned already. So I save this into a .yaml file, and then I just apply it. And then if Metal LB is already installed, it is instantaneous that it picks up these configurations. So with all of that being said, let's go ahead and get started. I'll go over my configuration here. I hope this font is big enough. My mom said she could read it, so that works. Now, Kubernetes involves a few components. What I have here is So I have 4 computers. I have a control plane master node, and then I have 3 worker nodes. Now the roles is interesting, but it's kind of outside of the scope for this discussion. The most basic way I can convey it is if you wanted, let's say you wanted these two to run production workloads and this to run like UAT or staging. Roles would play a good part in that. Roles would also play a good part in like build and release pipelines. Also authentication and accessibility roles come into play. But again, it's as flexible as it sounds. You can create a role if you can think of it. You can assign it to a cluster or an aspect of the cluster. Now, for a bare install, says. Oh, that looks ugly. So let me close this. There we go. That's a lot better. So this is just a out-of-the-box installation. Well, that's not true. I have MetalLB. But so anything Cube system is what you get out of the box. Core DNS is pretty sophisticated. It is a DNS service written in Go, and in my opinion, it's one of the more interesting and useful things written to come out of the language itself. But Core DNS is a minimal DNS provider. It's very flexible. You don't have to use it with Kubernetes. You can use it with whatever you want. But it is used in Kubernetes for the forward and reverse DNSing resolution, things like that. etcd is interesting. Again, it's another thing that is written in Go. In fact, all of this is going to be written in Go. So, fun fact, it's as easy as it is to criticize Go and Kubernetes, what they did with it is pretty incredible. I think, especially if your organization thrives on containers, this is the way to go. But etcd is sort of like a mapping software or a key value store, a secrets manager. It does all of those things, and again, it doesn't have to be used with Kubernetes. If you have something where you need to maintain key value stores, etcd, you might want to look into it because it's a pretty useful service. Now, the API server is exactly what it sounds like. It provides a listener, a sort of an open portal for you to interface with Kubernetes. The control manager does just that. It oversees all of the things that are running. Flannel is my network provider, so it does all of the addressing and IPing. Proxy, exactly what it sounds. And the scheduler is really interesting. It is a task scheduler that works in tandem with the controller, etcd, and the server. So anytime you run like a health check or anytime you do scaling, that is when the scheduler will kick in. Now, MetalLB has a primary controller, and then it has a bunch of listeners to do the networking thing. Again, this is out of the box. You could probably, if you encounter like performance or if you see some latency, you could probably check out the docs and scale it. That is something that I've read about, but I've never had to do because I've only ran it here at my house. All right, so this is a basic stack. So now what do we do? Well, first you need an application, and I just have a tiny Go server with some HTML templates, and then I have all of these configuration files, which may or may not be necessary. But to get a basic image, you would need to containerize it. You can use Docker, you can use Podman, you can even be elite as fuck and use CRIO if you wanted to get a runtime going for that. I just have a Docker file. And then I did this before knowing what I was doing. I created a Kubernetes directory, but kind of looking around at other projects, this is what most people do. I stored my Kubernetes manifests in here, and then I have this scaffold.yaml, which we'll look at in just a second. But inside of Kubernetes, I have my TLS certs, I have my deployment information, I have my ingress, which is sort of like an Nginx front door, and then I have my service. So let's go ahead and take a look at the service first, because that sounds interesting. And you can see here that if you're familiar with YAML or Docker Compose, this probably looks right at home. So we have a service type and then the metadata, it's named portfolio. We have some interesting specifications here. It is listening on 80 and forwarding to port 5000. This is what my container is listening on. And if you've used any sort of load balancing or application load balancer, this is the exact same concept. You can see it's TCP protocol. The type is load balancer. The selector comes into play mostly for identification, but also if you want to use multiple services or multiple services and deployments together. I think I said services twice, but I meant like services in GitHub or GitLab versus a Kubernetes service. So if you've ever ran a bunch of Docker containers, you probably ran into the issue where, everything on localhost can talk to container A, B, and C, but container A and C can't talk to each other. What the hell? This is something that solves that, and if you use Docker, you probably solve that with Docker Compose. This is very similar to Docker Compose. It is just for the Kubernetes orchestration system instead of Docker itself. Now, if we go into the deployment, we can see here that it's more or less the same thing. It's a little bit more involved. We have this thing called replicas, which we'll look at in a second. We have these match labels. This circles back to just what I was talking about. If you want to use multiple pods as a single cohesive web app or API, you will need to define and match these across your configurations or definitions. Now down here is where we reference the image. This is the username and this is the image name. Pool policy, if you've ever used Docker, you probably know what that means. It's irrelevant for this, to be honest. And then the container port, we can have multiple ports because we can have multiple containers. A deployment will push out a pod, but a pod is not a container. A pod can have a cluster of containers. So if I need Go, Redis, and Postgres, I can define all my ports here to listen on all of those, and then this single deployment will contain all three of those running. Replicas is nice for scaling. Since this is just a basic web page, I just have one replica, but I found that what you're running in your current environment often translates to running replicas. If you have 3 Redis nodes in your production cluster, then you can probably use 3 replicas in your Redis deployment. If you have 15 EC2 instances behind your production load balancer, you can probably have 15 replicas. Might get a lot more mileage out of this because containers have a smaller runtime and Kubernetes does a lot of black box things to optimize. But you can change that. The nice thing about it is you can change it if you're overutilized, and then you can just run and apply and instantaneously terminate or grow containers. You can also set up policies for that, which is a bit outside the scope of this, but you can set up scale policies. If CPU on all pods is 85%, it'll throw another pod into the mix. But let's get into it now. So this is the bare basics. So I'm going to go back to no, I'm not going to go back. I'm going to show. So right now we have just our Kubernetes service running. The traditional deployment is with kube control apply. And then it said the service was created, and then if you get service, look at that. We have a nice external IP because it's our load balancer. Cluster IP, we see it's listening on port 80 because as in the manifest, it was port 80 to port 5000. It's got the name up there, so pretty fast, pretty responsive, and at a glance, you kind of know exactly what it's doing. And if we delete this, I'm going to show you a better way, because this is something that I found kind of just reading and experimenting. It is an application called Scaffold. Scaffold is yet again written in Go. I'm sure you're picking up a theme here. And Scaffold offers a way to interface with Kubernetes while in your development workflow. So instead of, Docker build, Docker tag, Docker push, kube control apply. Instead of doing that, you can use Scaffold for all of those things. And I'm going to demonstrate right now by just running scaffold dev. And here is my Scaffold configuration file. You can see it's almost exactly like a Kubernetes manifest. A couple of references here. Now, how does Scaffold know what to do? You define your deployment, and then it uses the actual path. So here we have the Kubernetes directory. I'm in this path. So it uses just this, it treats this as the dot, and then Kubernetes deployment, Kubernetes service. So that's how it knows what to deploy. And I could define my Acme ones if I wanted to have TLS on this application. Pretty much it allows you to just roll out an entire stack networking application ground up in this definition. So I'm going to run scaffold dev. And you can see here, it's going to be pretty fast right now because I already built the image. So you can see it's got my application name, a timestamp, says server listening on port 5000. That's good because we know that the container port was 5000, but we know that our service is going to listen on port 80 and forward over to 5000. So let's just validate that. Sorry, I'm going to get into why I'm getting permission denied in a second. All right, so we have our 201 here, and it's port 80. So let's see what happens if we go to that IP address. All right, look at that. We have our application up and running, but how do we know it's working? Well, we see this hello Windows here. I'm clearly not on Windows. This was an elaborate prank that somebody committed on me, and I hate it. So let's go nano. Now I'm using nano because I did not change where my swap files are saved, and if Scaffold detects a .swp in Vim, it will it will do what I want it to do, but I don't want it to do it yet. So let's go to index. Let's go down to this awful. Okay, save, yes, yes. All right, so we wrote, and look at that. Scaffold detected a change. It's building our container, and it's going to push and then apply that container to the Kubernetes instance. So if I go back, you can see I'm still online. So Scaffold doesn't actually tear down the instance until it's done. And you see that deployment stabilized, everything's ready. Took 3 seconds, which isn't entirely true, but and then if we refresh, look at that. So it actually detects a change, and then it applies that change whenever you save your file. If there are issues with the build, let's just do nano main.go, and let me just add some nonsense here. Yes, main.go. See, it detected the change, and it's going through. Oh, God, it crashed. What happened? Well, the nice thing about this is the crash does not affect your development workflow, so the environment is still up. If there's other developers interfacing with this, that is the amazing thing about Scaffold, in my opinion, is that it waits for the new service or the new deployment to be online before it actually tears anything down. So let's go package main, let's save. And then now it's going to go through the build process again. You can optimize this quite a bit. If you're using something like Rust, man, go make a fucking sandwich or something, because these compile times are going to eat you for breakfast. But with Go, it's pretty fast. And you get a static binary. Okay, so now that that is done, we can see that, well, there were no changes because there wasn't a crash, but just let you know that the deployment is taken care of. So how do we get out of this? We Control C out of it, but first we can see that we have our portfolio is running. Well, I already showed the load balancer, but let's talk about that scaling thing that let's see, I think this is it. 10. Look at this. So you see, bam, listen, blah, 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 blah. It's like listening. It's freaking out with how many frickin' ports are listening now. And you see 8 seconds, 8 seconds, 8 seconds. So that's pretty cool. But let's make a change one more time. Let's just do, I wish I knew how this shit worked. So let's just add another comment here. Eat today, smile. Yes, yes, yes. And you can write filters in to where it ignores comments. So if you just add a comment, technically I could have had my Scaffold application ignore that. But I did this just to kind of show something, a little something, something. Okay, so we're deployed. We're still online, which is very nice. But if we go to get pods, there's only one pod now. What happened to all my replicas? Anytime you run Scaffold, even if you're in watch mode and it detects a change, Scaffold will always defer to the manifest. And if we go to our deployment, it just has one replica. So if you make a change with kube control, or if you make a change with Terraform and you're running Scaffold, just keep in mind that Scaffold is always going to defer to the manifests that are defined in the configuration file. So it can't lead to issues, because if your manifest is right, everything's going to work. But if you're trying to troubleshoot or debug something and things keep changing, just don't forget to run to the manifest. So, all right, so we can Control C out of this, and you can see that portfolio is deleted and service is deleted. So if we get pods, there's no pods found. And then if we go to get service, we can see that now it's just the Kubernetes service. So Scaffold, when you Control C, it tears down the environment that you're developing in. So how do you actually release? Well, you just run Scaffold run. And you can see here that I'm not in watch mode. It released a pod. We're still online, yay! And then you do scaffold delete to tear it down. So what if you have a dev environment and then you want to build to a production environment? Well, that's kind of what you saw I was messing with earlier when I kept getting permission denied. So Kubernetes defaults to this kube directory. And you can see here I have a prod config and I have a dev config. Right now I'm using the prod config. If I switch over to dev, and this is just a tiny one-liner that just exports that dev config file into my environment variable. Now, if I get nodes, you can see it's one. There's missing one. There's only 3 here instead of 4, and it's an entirely different cluster. So if I'm building on one cluster, scaffold dev, you can always just change your kube config variable to point at a different configuration. And once it's valid in one environment, if you want to release it to another environment, you just kube prod. You can see now I'm in the production environment again, and I would just run scaffold run to release to production. Now, you don't want to manually do that in the grand scheme of things. You want to have a pipeline, something like Spinnaker or Jenkins to do this for you. But if you are building something and you got it working in the dev cluster, the dev environment, you want to change it. This is a nice little way to do it. You just have this shell prefix, and then export your kube config to the config file that you want to use. And I just named it prod and dev, and that's really all it takes. So thank you guys for watching. I hope you benefited from this. I apologize that 90% of Kubernetes wasn't in the scope of this talk. I really just figured if people were interested in how I set up on-prem and how I run on-prem, this is pretty much how I do it. If y'all have any questions, or if y'all want to see another video just diving into a specific template or idea, let me know.